Welcome, ladies and gentlemen. So what I'd like to do is show you how to evaluate for our 6 trigonometric functions when we're given a point that is on the terminal side of a given angle. So remember, here's a coordinate point. Remember, coordinate points, have an x and a y coordinate. So if I was going to plot this here, well, I'm going to need an x and a y axis. Okay. Now, when creating my x and y axis here, remember -4 is going to tell me go to the left. So here's my x-axis. Here's my y-axis. So therefore, this is going to tell me 4 units to the left. So 1, 2, 3, 4. And then up 3 units. 1, 2, 3. Okay. Now, remember, this is a point that is on the terminal side of my angle. So I am going to start that from the origin, and I'm going to draw an angle out from there. Now, typically, when we talked about angles, we talked about having an initial side, right, was always on the positive x value, and then having their angle. But so we could say that that's our theta. But to evaluate our 6 trigonometric functions, again, we don't know where this value is. So what we can do is look into the reference angle of this angle to create a right triangle. And by looking at this, you can see that the reference angle is going to be right here. So if I use this angle, my reference angle, I can now create a right triangle by using the x-axis and this point. So therefore, now you can say that this line from the center to my point is now going to be our hypotenuse. Now, the length of this triangle is 1, 2, 3, 4, is -4, and the height is going to be 3. Now, it's very important. If here's my angle, remember, if here's my hypotenuse, that's where the angle's right. The side that's between the angle and the right angle is my adjacent, and then here is going to be my opposite. So again, what the question is asking us is, how do we evaluate for our 6 trigonometric functions? Well, so that means we need to identify sine of theta. We need to identify cosine of theta. We need to identify tangent of theta. Now, our hypotenuse, we do not know, right? So I need to figure out what my hypotenuse is going to be. So therefore, to do that, I'm going to have to use Pythagorean Theorem. Remember, my opposite and my adjacent are my 2 sides. So it's basically side squared plus my other side squared equals my hypotenuse squared, which in this case, I'll represent as c. Okay? Because I know a lot of people just remember a squared plus b squared equals c squared. So we'll just use c. Squared. OK, 3 squared is 9. Plus -4 squared is positive 16 equals c squared. So therefore, you can see 25 equals c squared. You could have also noticed that this is a Pythagorean triple, but that's OK. Then I take the square root of both sides, and you could say 5 equals c. And remember, that's positive. And the reason why it's going to be positive is because it's the hypotenuse. The hypotenuse is always going to be positive. Whereas the x and y, those are, those can be to the left, they can be down, they can be up, they can be right, they can be positive, negatives. But your hypotenuse is always going to be positive. So I've already gone through kind of what sine, cosine, and tangent are. I'll say them out loud, but I'm not going to write them. So remember, sine is opposite over hypotenuse. So in this case, it's going to be 3 over 5. Cosine is adjacent over your hypotenuse. So in this case, it's -4 over 5. And tangent is going to be opposite over adjacent. So that's going to be 3 over -4. Now, that's for those 2 angles. Now, the other thing is we have to do the reciprocal functions. Now, remember, the reciprocal functions, instead of opposite over hypotenuse, it's just going to be hypotenuse over opposite. Instead of adjacent over hypotenuse, it's going to be hypotenuse over adjacent. And instead of opposite over adjacent, adjacent over opposite. So therefore, I can actually just reciprocate these to figure them out. And it can go by pretty quickly. OK, the negative, again, doesn't really matter if it's in the numerator, denominator, or in front. It's not really going to affect it. OK, so now let's go over to 3/7. Let's go ahead and do that problem. Now, when go ahead and doing 3/7 here, we need to graph it, again, just like we did the last problem. OK. Now, in this case, you can see that my x value is positive 3, 1, 2, 3. My y value is 7, so 1, 2, 3, 4, 5, 6, 7. So again, going over 3, up 7. Oh, actually, I think I was, I guess you could see. Well, see, now this one's not as bad. You can see that I'm going to use this angle theta. It's pretty obvious to see theta being used. The reason why we couldn't use it again over here, and I should actually use these as the reference angle. Put those little, because I use a little hyphen right there for that. So here, we can use the theta, though. Here, we had to use the reference angle, which, again, if you have questions on the reference angle, taking the cosine of an angle or of its reference angle is going to be exactly the same. But here, I don't need to create a reference angle, or the reference angle is of the same angle, but I do need to create my right triangle. So now, by creating my right triangle, you can see your right triangle is always going to be a right triangle with the x-axis. Now, we can identify this is my hypotenuse, this is my opposite, and this is my adjacent. Remember, the way I always go through this is your right angle always points towards your hypotenuse, and your adjacent is always between theta and your 90-degree angle. All right, so now you can see that we know that our adjacent side is going to be the length here of x, which is 3. Our opposite side is going to be the height of the triangle, which in this case is 7. So again, we do not know what our hypotenuse is, so we have to go back and do a little math. So therefore, I'm going to have 3 squared plus 7 squared equals c squared. And again, I'll call your hypotenuse c. So 3 squared is going to be 9. Plus 7 squared is going to be 7 squared is going to be 49 equals c squared. 49 plus 9 is going to be 58 equals c squared. Take the square root, take the square root. 29, yeah, it's the 58. So therefore, c is going to equal the square root of 58. Now, when looking at this problem, you want to see, well, can I simplify the square root of 58? Because it's not it's not an integer like when using the Pythagorean triple. And whenever we have the square root of a number, you always want to see, can I simplify this radical at all? Well, the square root of 58 we cannot simplify. I could divide that into 2 and 29, but again, there's no square numbers that you can factor out from there, because 2 and 20, if you break it up, 2 and 29 are both prime numbers. So therefore, that's going to be our hypotenuse. Oops, square root of 58. OK, so now we know what the hypotenuse is. Now we can do sine, cosine, tangent. So I'll try to do these a little bit tight here. So the sine, remember, is opposite over hypotenuse. So that's going to be 7 over the square root of 58. Now remember, whenever you have a radical on the bottom, we're going to want to rationalize the denominator. We don't want to have the radical on the bottom. So I'll do this once, and then I'm not going to do it for the rest of them. Or I'm not going to show the steps for the rest of them. So we multiply by the square root of 58 on the top and the bottom. What that does now is on the top, that leaves me with 7 times the square root of 58. And then the square root of 58 times the square root of 58 is, or the square root of 58 times the square root of 58 is the square root of 58 squared, which is just going to leave you with 58. OK, so now the cosine of theta, that's going to be adjacent over hypotenuse. So it's going to be the same thing. But now we have 3 instead of a 7. So my final answer, once I rationalize the denominator, is going to be 3 square root of 58 divided by 58. Tangent of theta is going to be opposite over adjacent, which we like this one, 7 over 3. The cosecant of theta, now remember, it's going to be the reciprocal. Well, we're not going to want to use the reciprocal of this, because then the radical will go back in the denominator. So we're going to want to use the reciprocal of 7 over square root of 58. So that will give us the square root of 58 over 7. For the secant of theta, that's going to be the reciprocal cosine. So that's going to be the square root of 58 over 3. And then last but not least is cotangent of theta, which is going to be reciprocal of 7/3, which is 3/7. So there you go, ladies and gentlemen. That is how you evaluate your 6 trigonometric functions when given a point on the terminal side of an angle. Thanks.